In this segment, we will introduce the concept of Pom.xml in Spring Boot. A Pom.xml file is an XML file that is used in Spring Boot projects for managing dependencies, configuring build settings, and defining project information. It plays a crucial role in the development process as it helps in managing and organizing the project's dependencies, providing necessary information about the project, and configuring the build process. The structure and syntax of a Pom.xml file are defined according to the Maven build system. It consists of various elements such as project, dependencies, build, and plugins. Each element has its specific purpose and configuration. Defining dependencies in Pom.xml is important as it allows the project to access external libraries or modules required for the project's functionality. The Dependencies section in Pom.xml lists all the required dependencies along with their versions. Maven automatically downloads and includes these dependencies during the build process. Project information such as group id, artifact id, and version can be defined in the Pom.xml file. The group id represents the group or organization that the project belongs to, the artifact id represents the project name, and the version represents the project's version. Plugins can be added to a Pom.xml file to extend or customize the build process. Plugins provide additional functionality such as code generation, resource compilation, and test execution. They can be specified in the build section of the Pom.xml file. Customizing build configurations in Pom.xml allows developers to define specific settings for the build process. This includes specifying the source and target Java versions, configuring the packaging type, setting up repositories for dependency resolution, and defining various other build-related configurations. In this segment, we will deep dive into defining dependencies in Pom.xml. The Dependencies tag is a key element in the Pom.xml file that allows us to define the dependencies required for our Spring Boot project. Inside this tag, we can specify multiple dependency tags, each representing an individual dependency. For each dependency tag, we include the group id, artifact id, and version of the dependency. Additionally, we can include other metadata such as the scope and exclusions. The dependency tags are crucial for ensuring that our project can compile and run properly by including all the required dependencies. When specifying dependencies in the Pom.xml file, we need to include the group id, artifact id, and version to accurately identify and include the required dependencies. The group id represents the organization or group that created the dependency, while the artifact id represents the name or identifier of the dependency. Finally, the version attribute allows us to specify the specific version number of the dependency that we want to include. By including these three attributes, we ensure that our Spring Boot project has the correct dependencies. In the Pom.xml file, we can have dependencies that are required by other dependencies. These are known as transitive dependencies. Luckily, Spring Boot's dependency management mechanism automatically manages these transitive dependencies for us. This means that if a dependency includes other dependencies, Spring Boot will automatically include them in our project, without us having to manually specify each one in the Pom.xml file. This makes managing transitive dependencies easier and less prone to errors. The scope attribute in the Pom.xml file allows us to define the intended usage of a dependency. We have different scopes available, such as compile, test, provided, and runtime. Each scope specifies when a dependency should be included in the class path or packaged into the final artifact. Additionally, we can use exclusions to prevent the inclusion of unnecessary transitive dependencies. By specifying exclusions within a dependency, we can control which dependencies are included in our project, avoiding conflicts and unwanted dependencies. To create a new Spring Boot project, you can use the following command: mvn spring boot, run. This will create a basic Spring Boot project with a Pom.xml file. To add a dependency for a specific library, you need to edit the Pom.xml file and add the following code within the Dependencies tag. Dependency group idcom. Example, group ID artifact id example li array, artifact ID version 1.0.0. Version, dependency replace the values with the actual group ID, artifact ID, and version of the li array you want to add. To manage transitive dependencies in Spring Boot, you can use the scope tag in the Pom.xml file. To exclude a transitive dependency, add the following code within the dependency tag. Exclusions exclusion group idcom. Example, group ID artifact id example li array, artifact ID. Exclusion. Exclusions replace the values with the actual group ID and artifact ID of the dependency you want to exclude. The different scopes of dependencies in Spring Boot are: compile. This is the default scope and is used for dependencies that are needed for compilation and to run the application. Provided. This scope is used for dependencies that are provided by the container or server at runtime. Runtime. This scope is used for dependencies that are needed during runtime but not for compilation. Test. This scope is used for dependencies that are only needed during testing. System. This scope is used for dependencies that are not available in Maven repositories and need to be specified with a direct path. To specify the scope of a dependency in the Pom.xml file, use the scope tag as follows. Dependency group idcom. Example, group ID artifact id example li array, artifact ID version 1.0.0. Version scope compile. Scope, dependency replace the values with the actual group ID, artifact ID, version, and scope of the dependency. In this segment, we will learn how to build and package a Spring Boot project using Pom.xml. In this segment, we will learn how to configure the Maven build lifecycle in Pom.xml. Let's understand the different phases of the Maven build lifecycle and how to set up the default behavior of the build lifecycle. We will also explore how to configure custom build lifecycle phases or bind plugins to existing phases. Additionally, we will learn how to specify dependency resolution and control the order in which build lifecycle phases are executed. In this segment, we will cover how to build and package a Spring Boot project using the Maven command. We will start by understanding the command line options available for building and packaging a project. Then, we will learn how to use the mvn package command to create a jar or WAR file. We will also explore additional command line options to customize the build process according to our requirements. Additionally, we will understand the output directory structure for the generated jar WAR file and how to specify a custom output directory or final name for the artifact. In this segment, we will dive into understanding the generated jar WAR file structure. We will explore the content inside the generated jar WAR file and understand the structure of the meta-inf and web-inf directories. We will also learn how to access and use the resources within the jar WAR file. Additionally, we will get familiar with the main executable class or entry point of the jar WAR file. In this segment, we will explore the concept of Maven plugins and their benefits. We will discuss common Maven plugins used in Spring Boot projects and learn how to configure and use them in Pom.xml. Additionally, we will cover how to perform additional tasks such as code generation, testing, and packaging using these plugins. We will also understand how to specify plugin dependencies and goals. To configure the Maven build lifecycle in the Pom.xml file, you can use the build tag. Within the build tag, you can define various phases and goals for the lifecycle. For example, to configure the compiler plugin, add the following code within the plugins tag: plugin group idorg, Apache, Maven, plugins group ID artifact ID Maven compiler plugin, artifact ID version 3.8.1. Version plugin replace the values with the actual group ID, artifact ID, and version of the plugin you want to configure. To build and package the project using Maven, open a command prompt or terminal and navigate to the project directory. Then, run the command mvn clean package. This will compile the project, run any tests, and package the project into a jar.war file. The structure of the generated jar.war file in Maven follows a specific format. It includes directories such as meta.inf and web.inf, as well as files like manifest.mf and the lib directory. These directories and files contain metadata and configuration information for the project. For example, the meta.inf directory contains metadata about the project and its dependencies, while the web.inf directory contains configuration files for Java EE projects. The manifest.mf file includes information like the main class and class path, and the lib directory contains the project's dependencies. To integrate Maven plugins and perform tasks like code coverage or code quality checks, you can add the plugins to the Pom.xml file. For example, to configure the Surefire plugin for unit testing, add the following code within the plugins tag: plugin group idorg, Apache, Maven, plugins, group ID, artifact ID Maven Surefire plugin, artifact ID version 2.22.2, version, plugin. Replace the values with the actual group ID, artifact ID, and version of the plugin you want to configure. In this segment, we will explore the concepts of profiles and build profiles in Pom.xml. Profiles in Maven are a powerful feature that allow developers to create and maintain multiple configurations for their projects. By using profiles, you can easily build different versions of your project with specific settings and dependencies for different environments. For example, you can have a profile for development that includes additional logging and debugging tools, and another profile for production that optimizes the code for performance. Profiles can also be used to include or exclude certain dependencies or plugins based on the target environment. This allows for greater flexibility and modularity in your project. To define a profile, you need to add the profiles tag in your Pom.xml file and specify the configurations and dependencies for each profile. Maven will then build the project based on the active profile. Profiles are a powerful tool that can greatly improve the development and deployment process of your Spring Boot project. Creating and activating profiles in Pom.xml is a straightforward process. To create a profile, you need to add the profiles tag in your Pom.xml file and specify the configurations for each profile. Inside the profiles tag, you can define multiple profile tags, each with its own ID. The ID is used to uniquely identify the profile. Within each profile tag, you can specify various configurations, such as properties, dependencies, and plugins. To activate a profile, you have different options. You can set a profile as the default by using the active by default true, active by default tag. This means that the profile will be active by default unless another profile is explicitly activated. Another option is to activate a profile based on a specific property or environment variable. To do this, you need to use the activation tag with the property subtag. Inside the property subtag, you can specify the property name and value that will activate the profile. By leveraging profiles in Pom.xml, you can easily create and activate different configurations for your Spring Boot project. In Maven, build profiles are a powerful feature that allows you to define different configurations for specific environments. You can create separate profiles for development, testing, and production environments, each with its own set of properties, dependencies, and plugins. This means that you can customize the build process based on the target environment. To configure a build profile, you need to add the profiles tag in your Pom.xml file and define the configurations for each profile. Inside each profile tag, you can specify the properties, dependencies, and plugins that are specific to that profile. Once the profiles are defined, you can activate a specific profile by using the p command line option or by setting the maven_opts environment variable. When a profile is activated, Maven will use the configuration specified in that profile during the build process. This allows you to easily switch between different configurations without having to modify the codebase. Maven properties are a powerful feature that allows you to define reusable values that can be used throughout the build process. Properties are defined in the Properties tag in the Pom.xml file. Inside the Properties tag, you can define key-value pairs, where the key is the property name and the value is the property value. You can reference properties using the $property_name syntax. For example, if you have defined a property with the name version, you can use $version in other parts of the Pom.xml file. This allows you to parameterize the build process and easily update values that are used in multiple places. Properties can be used to specify version numbers, file paths, or any other values that need to be reused. Properties can also be overridden or inherited from parent Pom.xml files, which makes them even more flexible and powerful. Using Maven properties can greatly simplify the configuration of your Spring Boot project. Profiles in Maven are used to define different sets of configurations for different scenarios. They are defined in the Pom.xml file and can be activated based on various conditions. For example, to create a profile for the development environment, add the following code within the Profiles tag. Profile ID development, id properties env development, env, properties, profile. Replace the values with the actual id and properties you want to configure for the profile. To activate a specific profile in Maven, you can use the P or Activate Profiles option with the Maven command. For example, to activate the development profile, run the command mvn clean package p development. Build profiles in Maven are used to define different configurations for different environments. They can include different dependencies, plugins, and other settings based on the environment. For example, to configure a build profile for the development environment, add the following code within the Profiles tag. Profile ID development, id build plugins plugin group idorg, Apache, Maven, plugins, group ID, artifact ID, Maven compiler plugin, artifact ID version 3.8.1, version, plugin, plugins, build, profile. Replace the values with the actual id, group ID, artifact ID, and version of the plugin you want to configure. Maven properties can be used to make the build process more flexible. They allow you to define values that can be referenced in the Pom.xml file and other configuration files. For example, to define a Maven property, add the following code within the Properties tag. Example. Property example value, example. Property. Replace the values with the actual property name and value. In this segment, we will summarize the key points covered in this video. In this section, we will recap the key concepts and features of Pom.xml and Spring Boot. We will discuss the benefits and best practices of using Pom.xml, as well as explore Pom.xml for further learning. We will also discuss the importance of using Pom.xml for managing dependencies and how it helps in building and packaging Spring Boot projects. Additionally, we will cover the structure and syntax of Pom.xml. Now let's summarize the benefits and best practices of using Pom.xml. We will also discuss the next steps for further learning and exploration of Pom.xml.